Hi, this video covers working with 3D models in Pano2VR and shows you how to best import and manipulate 3D models, introduce you to new concepts and tools specific for working in 3D, and show differences in common panels and tools inside of Pano2VR. Pano2VR supports a range of formats for 3D mesh models and Gaussian splats. For 3D mesh models, we support GLB and GLTF. If you want to use a model with a different format, there are many free tools and websites to convert any 3D format into GLB or GLTF. For Gaussian splats, we already support a range of formats, among them SPZ and SOG. For a full list of supported formats, please check out the website. Starting with a new project, to import a 3D model, you can simply drag the model into the main viewer or the tour browser. When adding a 3D model to a project in Pano2VR, the main viewer turns into a 3D viewer, where you can view and manipulate your 3D model. It has a base plane with red and blue center lines representing the X and Z axis of the 3D space. Here in the Input Properties panel, you can see the position, rotation and scale values of your model in 3D space. One issue you can face when bringing in a 3D model is that different software can have different opinions where up should be in the model. As you can see, this particular model is on its side, and to correct that, we need to rotate it and maybe move it slightly to level it and position it on the base plane. The goal here is to bring the model into a position and orientation that's easier to work with. First, from the Viewer tool, select Manipulate 3D Model Mode or simply press M. As soon as you are in the Manipulate 3D Model mode, you will get a 3D widget to manipulate the model. You will get that same 3D widget when working with hotspots or camera points in 3D models, which we will cover in later videos. To rotate a 3D model by 90 degrees, it is best to turn on Rotate Snapping in the 3D controller at the bottom of the 3D viewer. So click this button or alternatively press 6 on your keyboard. Now we need to switch into rotate mode. You can do this by either clicking this button or pressing 2 on your keyboard. Now you can rotate the model by dragging the red circle representing the X-axis, and with rotation snapping turned on, which snaps at 45-degree increments, it's easy to rotate by 90 degrees. Now with the model having the correct orientation, we can also move it up slightly to put it on the base plane. To do that, you first need to switch to Move mode by either clicking this button in the 3D controller or pressing 1 on your keyboard. Now when we drag the green arrow, we can move the model up. Another issue you could run into when importing 3D models into Pano2VR is that the model could come in too big or too small. To show you this, I will add a Gaussian splat to the project. As you can see, this object is really small in the viewer, so we want to scale it up. To do this, switch into Scale mode by clicking this button in the 3D controller or by pressing 3 on your keyboard. Now we can scale the Gnome up to a good workable size, and finally we can rotate and move it up slightly. Now we have the model in a good position, we can lock it to prevent us from accidentally manipulating it later. So now after bringing models into Pano2VR, we can set up their default views. This will be the view that the model first shows in the output and also captures a preview image for the tour browser. For this we need to know how to control the 3D viewer. You can rotate the viewer by mouse, left click and dragging. You can zoom in and out using the mouse wheel, and finally you can pan the viewer by clicking and dragging using the middle mouse button, or if you don't have a middle mouse button, by pressing the Option key on the Mac, Alt key on the PC, and then mouse left click and drag. You can also navigate the 3D viewer with the keyboard. You can use the arrow keys or the keys for Q, W, E, A, S and D. The keys will do slightly different things depending on the camera mode, as I will show you later. Now I will define a default view for the Gnome by rotating and panning in the viewer, so that Gnome has a good centered position. When you like the view, simply right button click in the viewer and choose Set Default View. So now this view is set as the default view for the current model, and as you can see, a new preview image for the tour browser was generated as well. This preview image will also be used in the output for menus and hotspot preview images. Now I'll do the same thing for the model of the hotel room. Now that we have imported both a regular 3D mesh model and a Gaussian splat into Pano2VR, I want to walk you through the properties and settings specific to 3D models. Let's start with the Input Properties panel, and here, starting at the top, you'll see a field for type. Pano2VR will automatically detect the type of the 3D model you import. But in the rare cases that Pano2VR cannot correctly detect the type, you can manually set it here. Further down, underneath the label that shows you the input file for the model, we have options to optimize our 3D model on output. This is turned on by default and will optimize the textures of the model on output and create lighter versions for both desktop and mobile devices. Clicking the button on the right brings up a dialog that shows the optimization options. You can set different maximum texture sizes for both desktop and mobile, specify a format and quality, and also remove the textures altogether. This can be useful when you use the model geometry just for transitions and where the model textures are never needed in the output. Right under the Optimize on Output settings, you have an input field for mobile version. This is disabled by default, but if you unchecked Optimize on Output, you can provide your own mobile-friendly versions of your 3D model here, which we will show you later. But bear in mind that Gaussian splats do not have embedded textures, and therefore the optimization options are not available for Gaussian splats. Please be aware, at least for now, that Pano2VR only optimizes the textures of your 3D model, but it does not touch and optimize the geometry of the model itself. If you want to have advanced options to optimize both textures and geometry of a 3D model, there are again many free tools and websites out there to do just that. As an example, here is one of the many tools that you can use. Here we are using the GLTF Optimizer website to get lighter versions of a 3D model. With the GLTF Optimizer website open, we're going to drag in our mesh model. When it loads, you'll see that we've got various options down the left hand side. So under mesh, you can see we've got some options here. If you don't know what they are, I shouldn't worry, because this is very much a visual website. But if you hover over the options, you get quite good tooltips. Under vertex, we can have a look. There's more options here to select, and under textures, you've got even more options here, formats and the texture size. Now, the idea of using this, what we want to do is create two optimized versions, one for the desktop. So with that, I'm going to send the texture resolution up to 4096, and we're going to select apply changes. Once the optimization has completed, we can visually compare the differences. So let's just zoom into the model. So this is the original, and when I select compressed, you'll see that it changes slightly, but not too much. And if we have a look at the compression results, now this is very impressive. Texture sizes, they're down by 93.7%, and the overall file size has gone down by 91.63%. So what I'm going to do is I'm going to save this for the desktop. So I'm just going to download the file and then set this to be desktop. There we go. And now what I want to do is just change the textures, and I'm going to move that down to say 1024, and this is going to be for the mobile. So again, we're going to select apply changes, and again, once finished optimizing, we can then visually look at the original and then the compressed version. Here we've got a more heavier compressed because we're down on the resolution, but again, if we have a look at the results, the texture sizes, well, we're down by 99.61%, and again, the file size is still really reduced to 92.3. So again, really good. So let's just download this, and again, what I'm going to do here is just label this as being underscore mobile. Right, with that said, let's get back to Pano2VR and show you where we add these files. Looking at the Properties panel, this is where you update the desktop version, and as mentioned earlier, you need to deselect the Optimize option, which will allow you to set the mobile version. For Gaussian splats, you can use tools like SuperSplat to get a lighter version of your model. Here you can see I've opened up SuperSplat/convert, and to use this website all you do is just drag and drop in your Gaussian splat, in this case the gutvig.ply file. It's 99.2 meg in size. I'm going to change the format to SOG and select convert and download. Once it finishes, as said, it automatically downloads. If I look at my download folder, you can see that it's downloaded the SOG and it's 13.9 meg, so that's a significant difference in file size. Okay, so that's the Gaussian splat all done, so let's head back to Pano2VR. As before, looking at the Properties panel, you would add the lighter version of your desktop version here, and then here for the mobile version. Now I want to explain what preview image is for. Imagine you want the preview image in the tour browser and menus to be different to that of the default view. For that you can either pick an image file here, if for instance you have an image that you've created outside of Pano2VR, or alternatively grab an image from the 3D viewer. I want to use this opportunity to show you other camera modes the 3D viewer can provide. By long pressing this button in the viewer settings bar, you will see the 4 camera modes: orbit, fly, walk and fly over. If you want even quicker access to the camera modes, they also have keyboard shortcuts. Go to the edit menu and into the sub-menu for 3D models. Inside the sub-menu you'll find another menu for camera modes that will also show you the keyboard shortcuts. Orbit is the default mode and is good for when you want to view the model from the outside and rotate the camera around it. Flyover is similar to orbit, but here by dragging in the viewer, you move the camera at a constant height, as if you were flying over the model. Dragging with the middle mouse button or Option Alt click will rotate as if you were in orbit mode. Fly and walk modes are different and are good for when you want to put your camera right inside the model. So now, assuming you want to grab a preview image from right inside the hotel room, you switch the camera into fly mode. Be aware that when going from orbit mode to fly or walk mode, the camera will end up in the position of the light blue pivot point, so make sure this point is in a good position before switching modes. Now in fly mode you can use the keys on your keyboard that I mentioned earlier. Use W, A, S and D to move around, and Q and E to go up and down. If you want to move faster, you can press the Shift key whilst moving around. If you want to go even faster, you can toggle the caps lock key. Walk mode is different from fly mode as gravity pulls you down to the floor, and so you can no longer move up or down. To grab a preview image from the current view in the 3D viewer, you would press the Capture Preview Image button. This will also create a preview image file on your hard disk. Moving on, in the background image section, you can set a background for your 3D model. By default, we use type solid color and grey. So this is what it looks like in the output. Of course, you can pick any color you would prefer for the background. For instance, I'll pick this color. Now let's see what that looks like in the output. Alternatively, you can pick a panoramic background image as the background for your model. I've prepared a gradient image to use as the background panorama, but of course you could use any regular panorama image, so let's see what this looks like. Hide in node list is a new setting that is also available for regular panoramas, but can be specifically useful for 3D models that are only used for panorama transitions and should not show in menus in the output, or if you have a dedicated button in your skin to show the model and do not want to show it in the thumbnail menu. So here with this option checked, this is what it looks like in the output. No 3D model in the menu. Now for 3D models we have a new 3D models section in the input properties panel. At the top you have the position, rotation and scale fields that I mentioned when I imported the first model. The position and rotation fields have some special features. You can drag inside of them to spin the values. You can press and hold the Option or Alt key for faster spinning, or the Shift key to spin slower. They even support simple math, so if for instance you want to add a certain value to the value inside the field, just click the field and enter, for example, plus, and the value you want to add, then press enter. The units per meter field allows you to select the correct real-world dimensions for the model. This may not be necessary, but might be needed if you want to use walk or fly modes, where Pano2VR needs to put the camera at the correct eye level of about 1.5 meters for when walking and set the speed for when walking and flying. Most of the time the value of 1 in the units per meter field is correct, but you could also run into the issue where the model was created with some software where the unit was, for instance, set to 1 centimeter instead of 1 meter. Then you can correct that by putting in 100 into the units per meter field, because 100 centimeters makes 1 meter. If you did not create the model and are uncertain of the units being used, there is a way of getting a good estimate for that value by using the measure tool in Pano2VR. Here I've prepared a version of the hotel room model that uses centimeters instead of meters. When we now switch into walk mode, which should bring us to the height of about 1.5 meters, we will see that we end up much too close to the floor, which tells us that the units per meter is incorrect. Now I want to show you how the measure tool can help us figure out a good value for the units per meter. To do this, press the measure distance in 3D model button next to the units per meter field. Now the viewer is in measure mode and you will get the measure mode icon in place of the viewer tools. You can now pick a feature that you know or can guess the actual size of and then enter that size. In our example, we move to the entrance, double click the left side and then the right side of the door and then enter the length of say about 1 meter. Now you can see that the value for the units per meter is very close to 100, which shows us that the units were set to centimeters instead of meters. Moving on, here we have a setting for use model textures in transitions. This will only have an effect if you use a 3D model for transitions between panoramas. When checked, the textures included in the model will be used during transitions. Otherwise, the panorama images themselves will be projected into the model geometry during transition. Depending on the 3D model, one or the other might look better, so do your own testing when using 3D models for panorama transitions. Here I can show you what it looks like in our hotel room example. The next setting, Load Model on Start, can come in handy when you have a project with multiple models. When checked, this will load this model on start, possibly resulting in longer load times at first open. It also makes sense to have this checked if you are using a model for transitions that will need to be loaded anyway. If not checked, the start node will load faster, but there will be an additional loading time when you hit the model later in the tour. Next are materials. Here you can pick the materials to be used when rendering the model in the output. Keep original materials will use the model's original materials such as lighting and shadows, but there will be a slight change in the materials when going into a transition. Look at the back wall of the hotel room when we transition. When choosing Replace with Transition Materials, the materials may appear a bit duller when viewing the model, but then there will be no change in materials when going into a transition. So again, you may want to test and see for yourself which option you prefer and what looks best for you depending on the project. Now moving on to the user data panel. It is pretty much identical to what it looks like for regular panoramas, except for the auto tags section at the bottom. Here you can see we have new auto tags. One tells you that the node is a 3D model, and one giving you the type of the model, 3D mesh or Gaussian splat. Now we have reached the viewing parameters panel. At the top you have the section that holds the values for the default view. Here as usual you have the pan tilt field of view values for the default view, but additionally you have fields for the position of the 3D pivot point and the camera mode, which are also needed for the default view of a 3D model. In this section you also get a button that can help you find and move the pivot point, in case that it's hidden somewhere inside the model. When you click the button, the pivot point will get a 3D widget, so you can easily find and move it. If you want to move it in multiple steps, maybe along multiple axes, you can hold the Option or Alt key while dragging the 3D widget. But you can of course also move the pivot point into view by simply rotating and panning the 3D viewer. The viewing limits section allows you to specify top or bottom limits. This can be helpful if, for instance, your model does not look good at the bottom and you want to prevent people from seeing the underside. For instance, Gaussian splats are often very fuzzy underneath. Finally, we want to show you some of the new buttons in the viewer settings bar that are specific for the 3D viewer. The grid button toggles the base plane. The gate button not only toggles if the viewer should respect the viewing limits, but additionally toggles collision detection in 3D models. This can be useful if you get stuck in walk or fly mode and allows you to fly through walls. The camera modes button toggles through the 4 camera modes, or when long pressing it, gives you direct access to the camera modes. And finally, there are buttons for toggling ghost hotspots and camera connections, which will be covered in later videos. So this wraps up the settings and tools that are specific for 3D models. In up and coming videos we will show you how to add hotspots, camera points and control points to 3D models to get the most out of working with 3D models inside of Pano2VR. So that wraps up this video, and as always, thanks for watching.